It's good to see you once again as we continue this wonderful journey in additional mathematics. My name is Nanaya Wedu, and you can call me Senana. Remember to share this video, like this video, comment on this video when you see anything interesting or you want to ask a question. And don't forget to click on the notification bell and subscribe to my YouTube channel. In our previous lessons, we have considered the identity element, and previously we have looked at how we can identify the identity element when we are considering it in the table form. In this lesson, we are continuing to look at the inverse of an element, and we want to look at the inverse in a binary operation. But then we'll consider the inverse when we are considering the operations, which is addition, multiplication, subtraction, and division. So let's look at the inverse. So for inverse, basically when we look at the main operations, which includes the addition, the subtraction, the multiplication, and the division, it is just any number. So for instance, if you are using 10 as a number, that when we are considering addition, any number that when we add to that number, right, would give us the identity elements. And what is the identity element for addition? We know that the identity element for addition is 0. So what number can we add to 10 that gives us 0? So we know that 10 plus negative 10 will give us 0. So the inverse of 10 is the negative 10, right? So that is the inverse of the 10. So when we look at the examples here, the first one, 7, we see that the inverse of 7 and the addition is negative 7, because 7 plus minus 7 is what gives us 0, right? So this represents the inverse. Right? When we look at a fraction, for instance, 3 over 2, we know that we need to add negative 3 over 2 in order to get 0. So when we find the LCM here, we have the LCM to be 2. 2 going to 2, 1. 1 multiplied by 3 gives us 3. And then 2 goes to 2, 1. 1 multiplied by negative 3 gives us negative 3. 3 minus 3 gives us 0. So the inverse of 3 over 2 will be negative 3 over 2. Right? When we have half, the inverse will be negative half. And then when we have larger numbers like 1,200,453, and addition, the inverse will just be the negation of it. So negative 1,200,453. Because when we add these two, it gives us 0. So the inverse is negative 1,200,453. Now let's also consider when we are performing multiplication, right? So for instance, if I have 10, I want to look at a number that I can multiply by 10, and that will give us the identity element. And remember that the identity element for multiplication is 1. So if I have 10, I have to multiply by 1 over 10, so that I can divide the 10 by the 10, and that gives us 1. So the reciprocal of 10 in multiplication is the inverse, which is 1 over 10. So for instance, if I have 7, the inverse of 7 is 1 over 7, right? So 1 over 7 represents the inverse. Now if I have 3 over 2, I can multiply by the inverse 2 over 3. 2 will cancel 2, 3 will cancel 3, and that gives us 1. So 3 over 2 has an inverse of 2 over 3. And then if it's 1 over 2, it has an inverse of 2 over 1, which is the same as 2. And then when we have 1,200,453, the reciprocal of it, which is 1 over 1,200,453, would be the inverse of the 1,200,453, because that gives us 1. So I would like to leave you with this question. Is it possible to find the inverse for numbers when subtraction and division is used as an operation in general? So for instance, if I have 10, can we have division and then have a number that will give us the inverse, right, or the identity element? Or if I have, let's say, 7, can we have subtraction and then have a number that will give us the inverse, right, which is the identity element? We have an inverse like that. So in this lesson, we have basically considered the inverse of an element, where we've used some letters or numbers to be able to generally look at the inverse for addition and for multiplication, and then for subtraction, and then for division. In our next lesson, we'll be considering how we can generalize the inverse when we are dealing with variables like a and b, x and y. Remember to share, like, comment, and subscribe to my YouTube channel. See you in the next lesson.